In this video, we will learn how to write an assembly language program to multiply 8-bit number. So the first line of our code is dot model small. So small is a memory model and we can declare our data segment and code segment within only one program segment. So in this data segment, we have declared two variables as an 8-bit number because we have to perform the multiplication of 8-bit number. So the first number is number 1 and it can be declared as a DB directive, that is define byte. So whenever we have to declare this 8-bit number, that time we are using this define byte directive for declaration of this 8-bit number. So DB stands for define byte. Here we have declared these two numbers, that is number 1 and number 2 as a 8-bit number. So number 1 consists of 16H and number 2 consists of 10H. Now the next part is we have right here dot code. So dot code indicates that is the code segment of our program. And here we are writing the actual code of our program. So this is the code that we have written for our code segment. And at the last, we are writing here end of the segment and end of the program. So in this program, we have written these two lines for initializing the data segment in our code segment. So we are writing here move ax @data and move ds ax. And we are initializing whatever the variable that are declared inside the data segment that are initialized within our code segment after writing these two lines in our program. Now the next part of our code is move al comma number 1, then move bl comma number 2, and then mul bl. So these three lines are actual code of our program for multiplication of this 8-bit number. So first of all, what we are doing? We are passing the values of number 1 into our AL register. So after writing this move AL comma number 1, our AL becomes 16H. And we are writing here move BL comma number 2. Then we can write it as BL is equal to 10H because value of number 1 is equal to 16H and value of our number 2 is equal to 10H. So we are copying this value of number 1 and number 2 in our AL and BL register respectively. So the contents of AL and BL will be updated in our register. Now, what is the mul instruction? So in that mul instruction, we are writing here mul and then BL. So check that in that mul instruction, we have to check the value of our source operand. So the source operand is BL and BL is our 8-bit register. So whenever we are writing here mul BL and our BL is 8-bit register and it consists of value 10H. So what is the operation that we will perform in that multiplication instruction? Our AX will become AL into BL. So we have to check what will be the value of our AL and BL. So AL consists of 16H and BL consists of 10H. So after multiplication, it will become 160. But how these values are stored in that AX register? Because according to the operation, we can store the result into our AX register. So first of all, we have to check what is the source operand. So our source operand is BL register and we are using here for multiplication, that is AX is equal to AL into 8-bit unsigned source and our unsigned source is BL. So we are writing here mul BL. So our unsigned source becomes BL. So we are multiplying this AL into our BL, that is our accumulator, into our unsigned source. So after multiplication, your value is 160. And how we are storing this value into our AX register? In our AX, we have two registers, that is AH and AL. And combinedly, it will become AX register. So after performing the multiplication, our result will be store it as 0160. So after multiplication, your AH consists of 01 and our AL consists of 60. Then after multiplication, our control will be redirected to the move H, 4CH and integer 21H line. So this 4CH is the DOS interrupt that is used for terminating the program. And after using integer 21H, our program is terminated successfully. This is called as a software interrupt. And using this 21H, we are closing our program, and by with the help of end of the segment, we are closing our data segment and our code segment. And by using end directory, we are closing our program, that is end of our program. So now we will see how this one will be executed, and we can check the contents of multiplication, that is 0160 in our emulator. Here we have started the execution of our program by clicking on that single step mode of our operation. So first of all, our program execution will begins with that move AX at the rate data line. And here we are initializing the data segment in our code segment. So whatever the data we have declared in our data segment, that we are using in our code segment. So here we can see that our data segment value will be updated and the values are copy it into the AX register. So the address of data segment will be copied into our AX register such as 0710. Now we are copying the values of AX into our data segment. In our data segment, previously the contents are 07000. Now it will become 0710. Now the next line is move AL comma number 1. So we are copying the contents of number 1 into our AL register. So our AL becomes 16. Now move BL comma number 2. After executing this instruction, the value of number 2 will be copied into our BL register. So previously here our BL is equal to 00 and now it will become 10H. So we are executing here multiplication BL instruction and our value of AL will be multiplied with the value of BL and our result will be 0160 and that will be updated in our AX register. So our AX consists of 0160. Same like that, our AH consists of 01 and our AL consists of 60. So our multiplication code will be executed successfully. Now we have to terminate this program. That's why we have to call the DOS interrupt, that is 4CH in our AH register. So we are copying this content, that is 4CH in our AH register, and with the help of integer 21H software interrupt, we are terminating our program. So our program is now terminated successfully.